All right, darlings, we today are looking at exponential function basic notes. You're going to find them on page 19. So go to page 19 and you're going to pull up a graph screen. So get a new document, anything that's there, don't save, go menu, graph, and then we're going to do the first one of 2 to the x. So you use this arrow button right there. You can see 2 to the x, and I hit enter, and I see that beautiful looking exponential curve. When you start to see this formation, you're going to get comfortable that that is what exponentials look like. So Control T, and then fill out the table. So -3 is 0.125, -2 is 0.25, -1 is 0.5, 0, 1, 1 is 2, 2 is 4, and 3 is 8. We're going to do a nice plotting of that right now. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 2, 1, 2, 3, 4, right there, 1, 2, 0, 1, -1/2, a fourth, an eighth. And we can see that beautiful graph. So now we have that, and it looks gorgeous. Go back over here, hit tab to pull up the screen, and we're going to change this to 1/2 x. And we can see our values change a little bit. The bigger change is now the original one that I did 2 to the x is increasing, the 1/2 to the x is a decreasing function. So let me fill in the chart here. So now it's 3, 8, -3, 8, -2, 4, -1, 2, 0, 1, 1, 1/2. There's the 1/4 and the 1/8. So this one looks the same. 1, 2, 3, 4, 5, 6, 7, 8. This one looks the same. It's now been reflected over the y-axis. We can see it's still not coming across the x-axis. So that's important to notice there. So now we're going to look at page 20, and we're going to be talking about domains and range. So when I looked at these two graphs, if I had the 2 to the x and I had the 1/2 to the x, they both stayed above the x-axis. The domain was all real numbers. There were nothing that did not have a value. So we'll say the domain is all real numbers, and the range is going to be y is greater than 0. We're going to talk about 1 to 1. Remember, 1 to 1 means they've passed the horizontal line test. So it was already a function because it passed the vertical line, and now it will pass this as well. What does it tell me? It tells me they're going to have an inverse, and I know inverse means switch x and y. Okay, so in example 5, here we go. Determine the y-intercept of this function algebraically. Now, that's lovely. First thing I'm going to do is graph it so I know what it looks like. So I'm doing 7 parentheses to the x, and it graphs, and it's gorgeous, and I can see a bunch of it right there. I'm not seeing where I hit the y-intercept, so first I'm going to come up here, and I'm going to click on this, make this 12, just a bigger number, and now I can see the y-intercept very nicely. It's right there. So I know the answer to my question is 7, okay? Y-intercept is y equals 7. Now I can see there's a 7 in the question, and they want to show it algebraically now. So I know a y-intercept is 0, some number. So x is the value. So I'm going to plug in the 0 there for x. And anything to the 0 power is 1, so then it's 7 times 1, and there's my 7. We're going to say that this exponential function, as I look at my picture, it is increasing. The reason it is increasing, so I want to put that point there of the 7, 0, came down here, just like the one that we had on this page, the 2 to the x, the whole number there allows it to be increasing, where the fraction is what made it decrease. So it's increasing because the base is greater than 1. Now, I definitely did a rough sketch. I have my intercept there, and it's not the most curved function, but it's okay. Now, number 6, how does this one compare? So first, we can see we have the added extra here of the 4. So like always, go right to the graph screen, type it in. I'm going to use parentheses, 1 divided by 3, close them, to the x plus 4. And there it is, beautiful graph. Now notice the differences, okay? First of all, this one's now going down. Second of all, the whole graph up till now, they've perched right above the x-axis, almost touching, but not there. This one, they are raised up 4, if you will, okay? So let's answer the questions now. How does this graph compare? Well, the 1/3 to the x would sit right above the axis. Or have a range of y is greater than 0, where our new friend here has a range of y is greater than 4. Now, determine the y-intercept algebraically. We've done that before. That means that it's going to be 0 going in for x. So 1/3 to the 0 plus 4. Anything to the 0 is 1. So 1 plus 4 is 5. I got too excited there. So now we've got the point 0, 5, and this one is a decreasing function. Okay, and the asymptote is where the graph is coming to, but not hitting. So we're going to say that that comes right up to y equals 4. All right. So now, 21. What I want you to do, and we will go over these in class, I want you to do a rough sketch of each of these and see visually, going on the calculator, graph 2 to the x. We already did that on the first page. Then graph the negative 2 to the x. Where does that look? Then graph 2 to the negative x and see each of those so that you are used to what the negative in front did, what the negative in the exponent did. Now, we're going to turn to page 23. All right, so we're looking here. On page 23, now we're going to find equations. When I write equations of exponentials, they will be in the form of a times b to the x. Think of the b to the x as a unicorn, and this is a pony. A pony and a unicorn are not the same thing. One is real, one is not, but we won't get into that. Do not multiply those together. They are separate because this one is being held in these parentheses by that x. So first, determine a values and explain our reasoning. I want you to just take a minute and look at the patterns here. This x values going up by 1. Y values, they're jumping up a lot, which is what we expect by an exponential. We want to say, okay, the more I see of those, I'm going to say, all right, yep, that's a big jumps there. So to get from 5 to 15, I'm multiplying by 3. To get from 15 to 45, I multiplied by 3 again. And then 45 to 135, I multiplied by 3 one more time. The other thing you want to notice is here's our y-intercept. Okay? So now looking back at the graphs that we've already done, in this one, the 2 to the x there, we saw what was happening. Here I'm multiplying by the 2. That's what created those y values. When I plugged in and I ended up with my point of 0, 1. Here, I'm ending up with the point 0, 5. So this is our initial value, what happens when 0 is plugged in. And this right here is our b value of how it's multiplying. So what we're going to do for this is run a regression. So you're going to go to List in Spreadsheets, number 4. Remember to go up and label X and Y. So 0, 1, 2, 3, plug those in. Come over here, 5, 15, 45, 135. Get a new box wherever you are. Menu, stats, stat calculations. And before we only had linear. Now we have more pieces. We're going to come down all the way to letter A. And letter A is exponential. Just like before, change them out so they say X and Y. Hit enter, and there we go. It tells me that my A value is 5 and my B value is 3. So my final equation would say f of x equals 5 times 3 to the x. Notice the A value is the y-intercept. The B value is what I multiplied by. So we'll start with A is what happens when I plug in 0 for x, and the B is what I'm multiplying by. All right, here we go. We've looked at this one. It wants us to find an exponential equation again. They're giving me 2 points. They're giving me 0, 8 and 3, 1,000. So here, part A, use the fact that 0, 8 determines the A value. That is your y-intercept. So that is what you're going to use for your A value. Now, looking at, they didn't tell me every single value like they did up here. They jumped, that they went right up to 1,000. And they jumped, we would say, 1, 2, 3, 4 times. So thinking about that, we would want to say that we would look at the difference of the two and divide them out. So we're going to run a regression again and see what happens here. Come up here, label X. Whoopsies. Label Y. We have 0 and 3. Those are my two X values. Across from 0 goes the 8, and across from here goes the 1,000. So not as many points as we had the last time, but 2 is enough because we have 2 things to look for. Stats, stat calculations, get to the regression, exponential this time. And they're telling me that it's going to be y equals 8 times 5 to the x. So we can see that what got multiplied here was by 5s. And then, so if we started, the 8 is what we moved from. All right, an exponential function has these two following points. You need to find the value of the b. So there's 2 points, 4, 3, and 6, 48. You're going to run that one on the regression, and we will discuss the answer. Okay. Number 5. Let's look at one more. Number 5 gave me 2 points. So I am going to run the regression. Now, in the question, they said, find the exponential function. They will tell you what kind it is. You know what? 5 you can do. We're going to look at 6. Okay, 6 because it's a word problem. Read through it once, pause me, and it's telling you that it's an exponential rate. And they gave you that equation. They may not, but they gave it to you. So that's always pleasant. And if you know it's exponential, when you run the regression, you'll see it there. They tell you after 4 hours, the population is 98. And after 9 hours, the population is 189. You want to look at first time, our hours is the x. The amount of bacteria is our y. So we're going to first determine the function and the percent rate that the population is growing per hour. So first, run the regression. One more time, guys. And again, you can be moving ahead here on me if you've already run your regression. All right, so there is our function, and then it says the percent that the rate of population is growing per hour. So we have each hour here that we are going to look at. I have the hour 4 and I have hour 9. I can now go look at a table. So we're going to go to a graph. So I typed that in right at the top there. Nothing showed up because the values are much bigger. So Control T gives me the table, and I'm looking at my values there, and I can see the 57, the 66. So I'm going to make a quick table. And then I'm going to go to a calculator screen. And I'm going to say, here we go, the 66.081 minus the 57.947. And that would be divided by 1. And then do the next one, 75.356 minus 66.081. And I can look at those, that they are changing at a rate of 8%. Have a great night, guys, and I'll see you tomorrow.